Hi, welcome back to the AITX Community Podcast, the show where we go deep with some of the most interesting AI entrepreneurs, engineers, operators, and researchers across the state of Texas. I'm your host, Jake O'Shea. We specifically focus on Texas because we believe the engineering community here is severely underrated. People here are building incredible products and solving difficult and complex technical challenges. And our hope is that this podcast helps expose some of those exciting stories with the rest of the world. Today's guest features Jared Greene, an Austin-based engineer and the head of software at Base Power Company, one of the most promising and exciting energy startups in Texas. Base is tackling one of the toughest challenges in energy. How do we make electricity capacity more local and more resilient? Base Power builds modular distributed power systems that can augment utility grid electricity and installs them directly into their members' homes. The company's doing incredibly well. They just today announced a massive Series C funding round about 6 months after their $200 million Series B funding round announcement. They also recently announced that they've officially taken over the old Austin American Statesman building downtown and are converting it into a massive battery factory to help power future demand. Last, they shared that Base has to date distributed over 100 megawatt hours of power across the grid in Texas. Just to put that into perspective, 100 megawatt hours is enough energy to power about 3,000 homes for a full day, or to drive 1,000 Teslas from here in Austin all the way up to Dallas. Jared leads the team that is developing the systems to enable these distributed energy resources. Jared and I discuss his professional journey, beginning as an engineer at Opentrons Robotics, his work doing research on internet accessibility in Guatemala, leading to a role at SpaceX as a lead engineer helping design and build some of their Starlink satellite internet systems. Jared left SpaceX to join Base Power as their founding engineer and very first employee, and he's been one of the driving forces behind their software systems, coordinating power at scale. Beyond his technical accomplishments, Jared's one of those rare humans who thinks deeply about systems, people, and the long-term impact of what he's building. Our conversation touches on the philosophy of engineering, the future of local energy networks, how software and hardware interrelate and will play a bigger role moving forward, and what it means to build frontier technology right here in Texas. I really enjoyed hearing his story and think you will too. Now, without further ado, please enjoy this deep dive with Jared Greene. Okay. You ready?
Yeah, let's do it.
Awesome. Jared, welcome to the AITX podcast. Good to have you here today.
Thanks. Excited to be here.
Yeah. So I always like to start with all the guests to share a little bit of their personal story. So how'd you grow up? What first got you interested in technology, AI, etc.?
Yeah. So I grew up in New Jersey and right outside of New York. And when I was growing up, I had a great grandfather who worked on the first ever nuclear submarine. Came over from Italy, fled from Mussolini, and had like architectural drawings of these reactors that he would design like all over the house. And so really thought was very excited about building things, but also was under the assumption that basically drafting was what engineering was. And so uh, basically went through high school, was really excited about a bunch of different technical topics, loved math, got really, really deep into chemistry and did all of the chemistry Olympics and all that stuff. Then when I was looking at school, I looked at a few engineering schools and realized, engineering's not for me because that's just drafting. What I thought at the time, because both my parents did PR and did advertising.
Mm-hmm.
So it was like a very different world to me, but always loved building things and tinkering on things. I would take things apart, kind of thing. So eventually got to college. I went to Columbia in New York and was really excited about chemistry, realized that 10 hours a day in a lab was not for me. And so then ended up studying economics and really loved economics, still do. I think that economics was one of those things where it was a language with which to describe the world that I was looking for and hadn't found. And when I found it, I was like, oh yes, that's exactly kind of the way that you think about things like utility functions and thinking about the way that different people will use like probabilities to create trade-offs for themselves. That made a lot of sense. And so then I then went and worked at a bank for a summer and found the work really interesting. I think that looking at like the economy is really cool, and dealing with basically how value shifts around is interesting. But at the end of the summer, I was really kind of got to the point where I realized it was very much not for me, because I was getting really bored by the fact that your job will change, maybe you'll rise, but someone will take your job and their work will be exactly the same. You are not moving things forward in any way. It's just kind of you're part of a big machine, and you're just like shoveling coal into the machine.
Yeah.
The coal is interesting and it's cool, but it's still coal. You're still just making the train ride on the same tracks that it's always ridden on. And so I got back to school and was like, okay, this is silly. I really want to be building things. Like, I need to be making something where somebody else will take my job, or my job in 10 days or 10 months or 10 years will be fundamentally different because of my efforts. And so from there, it was obviously engineering. I also understood it enough at that time to say, okay, engineering, not just drafting, building real things. Started getting into computer science. Took a few robotics courses, and I was just totally hooked on it. It's like really excited about writing some code and then watching something move because of the code that I wrote was like, I was fully hooked on it. And so after this, I was looking for jobs after school, graduated, did CS, and
so you pivoted majors out of econ into CS?
I actually did both degrees.
Okay.
I ended up staying an extra year and doing CS and econ. But because I still loved econ, it was really interesting. It was fascinating, and I think I still use the underlying logic, but it was clear that it wasn't what I wanted to make my career out of. It's hard to like build new economies. So
that stuff's pretty set.
Right. Like, it can change, but infrequently and usually all at once. And so,
and it's usually not a great sign.
Yeah. So then after that, I went and I was looking for jobs that was related to robotics. There were 2 robotics firms in all of New York. It was Bumblebee Robotics, I think that's what they were called, and they were making drills for the rover to bore into the surface of like the moon for interstellar, or not interstellar, for space missions. And then there was a second company that was doing, called Opentrons, liquid handling robots. So you needed a PhD to go to Bumblebee. And so I said, okay, then there's one company. And so I went and started at Opentrons after school, and they were building effectively like an H-gantry liquid handling system.
Okay.
So
really quick, let's slow it down a little bit.
Yeah.
What is an H-gantry?
Great question. Imagine a 3D printer and then take the extruder off the end of it and put like a pipette that you would use in biology.
Got it. Okay.
And so it is basically moving the extruder or the pipette, and then it is pressing down on the plunger, and it's putting the liquid into like a petri dish.
And so now you can do like 10, 20 pipettes at a time instead of manually one by one.
Yep.
Pretty
exactly.
Cool. Okay.
That, and you can let it run overnight, and you can have the experiment be exactly reproducible. There are a few pretty cool things about the product, and it was a step function from where the biology industry was. And so it was very, very cool product. Still, company's still around, doing great. It's like really a huge deal for the biology community. But for me, I was just really pumped about getting to write some code and then watch this robot move around. And it was like the funnest thing in the world. I had a blast doing it. Ended up writing the driver that was like the underlying driver for their next generation system. And just great job. And it was a startup. And so I was doing a lot of work that no one should have reasonably made me responsible for. And like any startup, it forced me to upskill.
If you can solve a problem at a startup, they'll give you more until you can't solve them, which is kind of the beauty of it.
Yes.
You mentioned one thing that I think will become kind of a recurring theme through this conversation, but you said you wrote some of those initial drivers. So one thing I'd love for you to kind of explain to the audience is, what's the difference fundamentally between firmware and software? Because they're both code, right? They're super different in a bunch of different ways.
Great question. And I wish there was a clear and obvious answer, but basically you have to draw the line somewhere. And the place that I would draw it is at a certain point on the hardware, in the code that you are writing, you need to be hardware aware versus hardware agnostic.
Okay.
And so I had to, when I was writing this driver code, I had to understand exactly what bits were going to be written onto a wire, because I knew that the hardware is going to respond in XYZ way. And then that driver would expose a command that said, move to position XYZ. And now whatever code called that, which I ended up writing later on, that did not need to know exactly what motor, how the motor was working, what like motor controller we were using, and even the setup of the system, right? You could switch to a whole different set of actuators, and as long as you change what is happening within the driver, you can abstract that away.
Got it. So a driver is kind of this intermediary layer that takes all this software you've written and makes sure that it runs correctly on the actual hardware system.
Yes, and it's aware of the hardware, so it understands what that hardware actually is. Where you should be able to, if you are writing or if you're following great software practices and building a system well, you should be able to swap out what is beneath your what's often called like a hardware abstraction layer, HAL, and have your application not change if you have, for example, changed the type of motor you're using, but it still has the same capabilities. So that is like an indication that you're building a project really well.
Nice. Okay. I'm familiar with drivers because of installing printers back in the
day. But that's exactly it, right? Your computer only knows I'm going to send it document to print. The driver needs to know, oh, this printer actually needs this document in that format, and it needs to wait before it receives it, and there are specifics about the hardware itself. That's why when you change out your printer, you sometimes need to get a new driver because it knows about how that printer works.
Yeah, awesome. Thank you for clarifying.
Yeah, totally.
So you are building out these drivers and eventually some of the software for these H gantries for biology.
Yeah.
Where does that kind of lead you next?
So then I actually took kind of a bit of a different turn. I'd written up this proposal for a project that I was really excited about, to go to Guatemala and take a look at the infrastructure, the internet infrastructure around Guatemala. I'd spent a little bit of time there and had gotten pretty excited about and interested in how the infrastructure dictated parts of my life, people's lives in general. I ended up setting up some Wi-Fi networks and some like local area networks for a family that I was staying with, like simple stuff like Wi-Fi router, like string some Ethernet cables. But it was stuck in my mind for basically like the year before that, or the year after that. Just thinking about how seeing internet introduced into the community gave people access to a lot of things that, like education, communication with friends, it's just really changed a lot of people's lives.
Whole new world.
Yeah, I mean, it's totally different. Like think about when you got the internet.
Yeah,
like,
for real.
It's pretty important. Yeah. And so wrote this project proposal and ended up making the right call at the right time to the right person, some information I found online, and eventually got my project in front of Vint Cerf, who is the father of the internet. He was on the RFC that defined TCP/IP. It's like the fundamental protocol that the internet runs on top of. And so the internet was created by a lot of people, but Vint Cerf is basically one of the key folks that developed the technology. And so he emails me back, or I talked to somebody that forwarded to him. He emails back. He says, "Okay, how much money do you need to go do this project?" And basically, totally blew my mind. It was hard to believe that.
Because you're probably like a 23, 24-year-old kid at this point.
Oh yeah. And I put together this proposal, and he comes back and he says, "Okay, how much money do you need? Put together a budget." And so I'm like, okay, I got to make this budget as small as possible. So because I have this man on the hook right now. And so I put together a 1-year budget that is $7,000 for like the full year, room, board. I forget that taxes exist. Like it's like this really ridiculous proposal. Now I realize he looked at it after I sent it over. He was like, "Oh, this kid is like, it's almost silly how cheap this is."
Yeah.
And so he said yes, and then I went to Guatemala for a year.
Cool.
And yeah, so this is like what ended up this is why I left OpenTrons. Basically, I like thought the job was really cool and I learned a ton, but then had to go and go on what was a combination of a really awesome technical journey and also just an adventure right out of college.
Very cool. What exactly did you do while you were in Guatemala?
So it's a little bit ridiculous. So he said, "Okay, I'll fund this." And I asked him, "Okay, can we just give it a name?" And he said, "Okay, what name do you want?" I said, "I just wanted to pick something that when I got to Guatemala, they would look at it and say, okay, this is legit."
Yeah. They trust you.
Yeah, exactly. Yeah. It's like, okay, I basically have to like iteratively build trust here. And I have a seed of like kind of competence or validity from like Dr. Surf.
Yeah.
And now I gotta build on top of it. So I make business cards for myself. I get like the title, and then I land in Guatemala, and I go and I start just talking to universities and trying to get a professor to work with me. So I find a few professors, and then I end up like helping them kind of TAing some of their classes.
Well, and what were you pitching them on? Like, what were you asking for them to work with you on?
So what I wanted to do was I wanted to run a project by which I overlay network performance with political engagement. And so my big question was like, is there a causal relationship between improved network performance and increased political engagement in indigenous areas? And so the general hypothesis was you have some preference hierarchy. Like to say it, I don't know, pretty simply, is like the faster your website loads, the more likely you are to not leave it before it loads.
Yeah. Right? And the more likely you are to read more web pages. And
yep.
Yeah.
Exactly.
Makes sense.
And so if your preference stack, the top one, I'll wait a long time to see the photos from my family or from my wedding. Probably lower down on that is reading an interesting article, and then lower down on that is if I'm not incredibly politically engaged, right, I'm less likely to interact. And so as your network performance improves, more likely to engage.
But that's the theory, at least.
That was the theory.
Cool.
Yeah. And so I get there and I'm basically trying to figure out, okay, how do I actually do this? And end up slowly building relationships throughout the country, and focus in on getting some survey questions into a national survey that gets sent around the country, and trying to get access to data from one of the large telcos, from the largest telco in the country. And at the time I was like, okay, this is going to be impossible. I don't know anyone in this country, right? Don't have any connections. And I'd say that my basic strategy was I'm gonna wait them out. And so I would just wait in people's lobbies or wait in people's offices. It's like I have unlimited time because this is the only thing I'm here to do. So I will wait. I'll come back tomorrow. I'll come back the next day. I'm just
At some
you are
point,
the
you're gonna have
person.
to
Yeah,
talk to
yeah,
me.
you got to talk to me eventually. And that actually worked for in most cases. So I ended up getting some like professor relationships, and then what I would do is I would say, okay, can you sign on to be an official advisor for the project? And now, okay, now I have these two professors that are official advisors, and it's backed by Vint Cerf, and it has this fancy title. Now let me go and get like an industry partner.
Yeah. What was the title, by the
Basically.
way? I don't think we.
Oh, it
specified
was
that.
see if I remember this correctly. It was Internet and Democracy Research Scholar.
Nice.
Yeah.
Yeah.
I was like, that sounds official.
Super legit.
Yeah, exactly. Sounds like someone else has had this title before, but and that's what I was going for. Yeah, and so I spent a year doing this, and eventually, by luck and just waiting folks out, was able to get a few questions added to a national survey, and got access to all of the data and a seat in like at the largest telco in the country. And I was really excited and honestly pretty yeah, pretty pumped about being able to get through both of these big walls. And then I get to the end and the data does not match, in that the survey is run every 2 years and the telco deletes their data every 6 months.
Oh,
And
geez.
so I like could not do this longitudinal study that I spent a year working towards. And so that was a little bit heartbreaking at the time,
Yeah.
but it definitely like learned a ton and got a chance to really dive deep into the like communication infrastructure of the country.
Yeah.
And so sat with the telco as they were planning out new capacity, got to look through all of their like their call records and different connectivity metrics, and so learned a lot about it. Yeah, but it was really a great project, but in the end, it was not able to make anything happen.
Oh, fair enough.
Yeah.
Where do you stand on your original hypothesis? Like, do you think it's accurate that greater connectivity leads to greater political engagement, or is it still too much of an open question?
Good question. I'll give a hypothesis based on intuition and no data.
Cool. Yeah.
So,
I'm basing
just to
my
call
opinion
it
on
out.
intuition at this point. So, yeah.
I think it's less correct than I'm less convinced by it now.
Okay.
For two reasons. One, I realized that the items at the top, you can just continue to consume those items. Right? So you can just look at more and more pictures of your wedding or more YouTube videos, and I'm not sure that you actually end up exhausting that top layer.
Oh, yeah.
And the other piece of it is related is there's just more content. And so if you're not interested in it, there's basically an infinite amount of items that you can be interested in.
Yeah.
Now you can generate things that you're interested in. And so I think it's less convincing to me now.
Yeah. That's a fair point of view. I feel like also America has this unique culture where politics are very much like entertainment. And so it gets recommended on your feeds. You watch whatever political show for fun, 24 hours news cycle, whatever. The rest of the world's not really like that. So there's not as many opportunities to kind of expose you or get you engaged to that type of content in Guatemala as there would be in America.
Yeah, that's interesting. I think that each country has a pretty unique way of dealing with politics.
Yeah.
And so there are some where, while I was there, they had large national protests and actually like ousted the president of
Oh, wow.
Guatemala. Yeah,
Okay.
it was a very big deal. Like there was some pretty serious political stuff going on.
It's an insane time to be studying democracy.
Yeah,
in a country.
yeah. I thought this is like what I was quite excited about when I was there. I was like, oh, this is the perfect time. And so I would go and I would drive through. I had this, I bought this like $700 motorcycle.
Nice.
And I would like drive through the mountains and go and hang out like in indigenous areas for like days, weeks at a time. And then I would sit down with people and say like, oh, are you engaged with what's happening right now? It's like incredible. And they'd say, oh, sorry, what's happening? Like, and I just realized that if you talk to the right person, they would be quite engaged.
Yeah.
But there are a lot of people that just didn't care, didn't feel impacted.
It's not high enough on their preference stack.
Yeah, exactly. Yeah.
That makes a lot of sense. What was kind of the big takeaway from that whole experience? Like for you personally?
So I came back and I was hoping that I would go there and find a way to basically change, like improve connectivity, right? Use it to motivate the investment and the expansion of the infrastructure. And the thing that I came back with more than anything was a deeper understanding of why infrastructure is difficult to build and the types of techno-economic like interactions that really drive why things are built where. Mm-hmm. And so going through the mountains, you think about how difficult it's going to be to run fiber like through or atop this mountain.
Yeah.
Right. And then you get to the top and it's like 500 people living in a community up there and you're never going to pay it back. Like the infrastructure investment there will never work.
Yeah.
So I came back pretty, honestly, a bit bummed, thinking about like how do you fix this problem? Like, I really don't see the path forward on bringing internet to the world or bringing electricity across the world. Right? You have like billions of people that are not electrified and billions that also don't have connectivity. So I was hoping I'd come back with the solution. It turns out it's actually a pretty hard problem. Yeah.
Unless you can make it economically viable to do, corporations are probably not going to do it.
Yes.
Yeah.
And they shouldn't, right? Even if governments can, they can do it, but there's a lot of waste. Like the techno optimist in me, which is honestly a big part of me, is quite bullish on you got to solve it at the technology and you have to make the numbers work.
Yeah. I mean, Starlink solving some of the issues of running fiber, right? Electrification, not quite yet, but maybe we'll get into this with base power in the future.
Yeah. This is what happened next. Like I went back to SF, spent a few months there hanging out with a buddy, and then I heard about Starlink and it just clicked. I was like, oh, this is it. That's the answer to my problems here and the world's problems. And so I went and joined Starlink, and they had launched 60 satellites at the time, just like the 0.9 satellites, really, really early first version. It was still very much a crackpot idea. And joined them, very determined to bring internet to Guatemala.
That's really cool. Let's talk a little bit about it being a crackpot idea. Because I think today everyone's like, oh yeah, Starlink. I could go to like Home Depot and for $500 be connected wherever in the world. But at the time, you've got a company that they had done some successful launches, right, of satellites, but never of like humans, never reusable. Like it was a very different company back then. They're like, yeah, we're going to create a giant grid of satellites that are orbiting the Earth at the same time. And no matter where you're at, this system's going to be able to ping the right one and beam you down internet. It's a pretty crazy idea. Like, was it just kind of the mission or that vision that really drew you to there where you're like, oh no, I need to see this a reality? Or did you have other influences where you're like, no, actually, this is pretty viable. Let's make it real. Or was it a combination of kind of those two?
Yeah, good question. I'd say even to expand on the like craziness of the idea. Like several companies had gone bankrupt trying this exact idea. Like, and not just any companies, but like Bill Gates funded a project that was also supposed to do like global satellite internet. And I think they were using LEO as well. And also it failed. Like this is it is a provably extremely difficult economic and technical problem.
Mhm.
I would love to say that I had some incredible insight on the technology, but I think it was more that I wanted to work on something that had a legitimate probability of failure, and if it worked, would have a massive impact on the world.
Yeah, very asymmetric outcomes. Either
Yeah.
it doesn't work at all, or it changes the way people access internet around the world.
Exactly.
Glad that it. Was
Yeah, you got it ended up like that. Yeah.
Cool. So you joined SpaceX. I guess maybe a bit of a tangent here, but like, what was that interview process like? I feel like it had to be pretty intense. So just like curious if you have any stories or insights from that.
I actually think mine was a little bit odd because I joined to do a job that I never ended up actually taking.
Okay. Tell me more about that.
So early on, they were building a team that was going to do go to market for Starlink, and the Starlink go to market problem is extremely difficult. It's like every country in the world all at once. It's a really hard problem.
There's not a wedge market for
yeah,
that, really.
Yeah, exactly. That one is extremely hard. Actually, one of the folks now that I work with quite closely at Base ended up leading the market entry and go to market for Starlink, and really crazy smart guy, Cole Jones, on our team, and ended up doing this exact thing. But so it was my case for the interview was, what price should Starlink be?
Okay.
And so it was very much non-technical. I dug into the technology of the system just because it was super cool and I was really interested about it. But really, I think what it was pulling from was I just spent a year traveling around a developing country that was working on internet and seeing how the infrastructure was working. And so I think that's really where it came from. And I was super excited about getting a chance to contribute to this in any way I could. And so that process was, it was pretty intense, but I think it was, I had very strong opinions on the right way to do it. And so I think that came through.
Yeah.
And I was really excited about it. I mean, it was kind of a role that I felt like was the obvious and correct next step for me.
Yeah. Very serendipitous.
Yeah.
To come from what you had just been doing and see this opportunity.
Yeah, exactly.
So you said that you ended up not really working on what you were hired for. It sounds like you were kind of hired for go-to-market. What did you actually end up working on once you joined the SpaceX team?
So I started off doing simulations for the Constellation. During the interview, they were like, "Oh, are you? Tell us a little bit about your technical skills," because it was kind of a nice to have. And then as I told them more about stuff that I had done, the amount of time that they wanted me to spend doing constellation simulations increased, like throughout the onsite.
Yeah.
And so at the start of the day, it was like, yeah, you just spend a month there because you need to understand how the system works. And then by the end, it was like going to be a 9-month stint starting on some of the simulation work. And so I started off basically doing answering questions for the system, like how fast should the gimbals for antennas be able to move?
Mhm.
And what should the acceptable field of view be? What should scan angle be for antennas? Those kinds of questions. And then as I did that, basically started to learn more and more about the system. And like, I think most organizations that are moving quickly, at that point, I would think of Starlink very much like a startup.
Yeah.
There were, I think, 100 engineers on the team, and we were just producing like first components. Hadn't started producing user terminals yet.
So you had launched systems into space, but those were not the satellites that would actually be beaming the internet down, or you were more focused on the like physical components that we have down here?
My focus or the network's focus?
The network focus.
Oh, so at the time, this was in 2019, I think August 2019. And what had happened, what had been launched were some test satellites, some like early test systems. And we were checking functionality, seeing if the vehicles were working, that kind of thing. And the user terminals weren't out yet.
I think you guys also had a strategy. My understanding of this is you would basically drop a big bulk of them at the same time.
Yeah.
And that hadn't really been done before either, because there was lots of collision avoidance issues and things like that. But, so you were kind of testing out some of those systems?
This is, as a team, we were doing basically the early architectural, we were answering a lot of the early architectural hypotheses that were underlying the way that the system would end up getting built.
Yeah. Okay.
And so like, can you just drop these satellites out there? Can they like quickly gain attitude control? Are you able to, and this is a huge question, it's like, are you able to actually establish reliable comms?
Yeah.
And can you, those were a lot of the big questions. Also field of view challenges were a big one. And for systems like this, for distributed systems in general, but also for physical systems, it's like a big part of working with hardware is for software, you can get, production is always going to be different than your test environment. And your scale will be different, and you'll see things like, I don't know, your cloud instances will shift around. And so it won't be perfect as if you are testing it on your like development systems.
Yeah.
But when it comes to like testing out either code that runs hardware in software land or testing it in the lab versus in the field at scale, it is a totally different story. It's like testing, like, what's it called? Practicing like you're going to play. Is the way we talk about it a lot. It's like putting systems really into the wild, into the environment that they're actually going to experience. There is no test like it. It's like 1,000 times more effective. And so we really, that was basically where we were, what the stage was in the development process.
Getting the actual real world data to then refine some of these decisions and make it viable. Cool.
Yeah. And so I worked on some of the early simulations, making some decisions for the Constellation, and then ended up bouncing around to a few projects. And so basically ended up leading the engineering effort for brightness on the satellites. And so the satellites ended up being optically reflective. There's a particular geometry and some like optics that go into it, but basically they were bright at dusk and dawn if you looked at them in a certain
angle.
Yeah, basically.
Is that why you can kind of sometimes see them falling through the sky? Pretty cool, because you're at the angle where you catch the reflective surface.
That, and I don't want to get too deep on this, but there are two different types of reflectivity. There's specular and there's diffuse reflectivity. And so diffuse reflectivity you'll be able to see it from most angles. And then specular is like a mirror, where if you shine light at one angle, you'll only be able to see it from like a very specific angle.
The one that corresponds to whatever.
Exactly. Like an angle that matches the angle of incidence. And so you ended up actually being able to see the satellites from a lot of angles. And we went through a very big engineering effort, and SpaceX is still going through it. Like, they continue to work with astronomers, and they continue to think about brightness. Brightness was never something that people that were launching satellites actually thought of meaningfully. And so this was a new and tough problem. Worked on this for a while.
Why is brightness so important for Starlink satellites that provide this sort of service?
Brightness is really important because for astronomers that are doing all types of different science, really valid science, really awesome science that is discovering phenomena around around space, like all
like
across
deep
space.
work.
Yeah.
Space research.
Deep space, like things that are near Earth, asteroids that are headed towards Earth. There is an incredible scope of scientific research that is occurring that involves looking up at the night sky.
Mhm.
And a good amount of it does long exposure images. And so if objects are very bright, you can saturate pixels in a sensor, and that can
Throw it off.
slow down scientific discovery.
Okay, so you guys had to make sure that you could at least measure these so you could share that with astronomers to make sure it didn't.
We made it darker.
Oh,
So
okay.
we made quite seriously took the engineering challenge on, and we're launching mitigations into space. I think weeks later.
Wow.
We were running first experiments. This was taken very seriously.
Startup speed.
And we were really, really taking it seriously. SpaceX continues to do analyses here and continues to work on it. It's part of the development process now. They've it was not an effort to keep people quiet or anything like that. Very much took the technical challenge head on and it's continued to work on it.
Nice.
Yeah. But worked on that for a while. And then worked on a few different projects from there. Basically, would hop around to some of the hottest projects at Starlink for a little while, and then eventually for my last few years there, ended up getting really focusing on the topology that is constructed with free space optical links between the satellites.
Okay. All right.
Sorry. Let's take that back. Okay. The satellites have space lasers on them.
Sick. Okay, cool.
It's super sick.
Yeah.
And space lasers allow you to send data from one satellite to the other.
Okay.
And why do you want to do this? There are a bunch of cool things that it enables, but one of the big ones is if you want to, if you have a plane that's in the middle of the ocean and you want to be able to stream Netflix, do an awesome video call, have super low latency, super high bandwidth connectivity, then, and because of the way that the system is constructed, which we don't have to get into, you basically need to send data from one side to another.
Okay. And the lasers are the way to do that.
Mm-hmm. Yeah. And so you need to figure out, okay, what laser should point at what other laser, and then you end up effectively building a graph. And how should you build this graph in a system that is changing in real time is the problem that we were solving. More
distributed systems problems with, I guess, changing nodes on the graph, because you could connect from that plane, then disconnect, then connect when the plane is moved. And pretty meaty problem.
Satellites are moving past each other fast. Satellites orbiting the Earth in 95 minutes. And so there are a lot of problems related to it. But at the end of the day, it's a graph problem like many others in computer science. And so worked on that for a while, and eventually got the system to, partly my efforts. The hardware was a huge part of it. The vehicle structure was a huge part of it. There were a lot of teams that were engaged in this, but eventually was able to get the system to a highly reliable, highly performant system.
Very cool. Yeah. Well, one of the things that fascinates me about space is that this concept or idea that if you're in orbit around the Earth, you're actually just falling towards the Earth at the same speed that the Earth is falling towards the sun, which is then falling towards the center of the universe. And you're not really going in motion, you're just falling. But because you're falling at the same speed, you stay in the same space.
Yeah.
Are Starlink satellites in kind of perfect orbit, or are they a little bit slower to where they're eventually going to come back to Earth and they need to send another one up to replace them?
Good question. So to expand on that a little bit, one thing that's always kind of blown my mind is the velocity of a satellite that is in space, like the vast majority of it is still you can still tie it back to the rocket that initially put it into orbit.
That's crazy.
It is like there is a super small amount of change in velocity, or delta V, that is ever produced or ever impacted, ever impacts a satellite, and almost all of it is still the same momentum that initially put it there.
Yeah.
Which is really cool.
It's fascinating.
Yeah.
Yeah.
So this is not Starlink specific. Any satellite that is in low Earth orbit, what happens is as you go further and further away from the Earth, you see an exponential drop off in the density of oxygen that is in like free space.
Yeah.
There's not like a line that is like, now you're in space, there's zero oxygen.
Yeah.
And so the closer you get to Earth, the more oxygen there is, which means the more drag there is. And so this is like a very small amount. We're talking about, I don't know, over the course of months to compensate, you would need an amount of acceleration that's close to like a book. Maybe it's like a quarter per week, something like that.
Yeah, very, very small.
Like it's a super small amount that you need to compensate, but eventually you will fall out of orbit if you do not have something to create thrust in low Earth orbit. And so this is something that, I mean, is well documented. There are thrusters on low Earth orbit satellites.
Every single one, not even just Starlink.
Yeah.
Yeah. Okay. Cool. I love talking about space.
Yeah, me too. It's super cool.
Very cool. So pivoting back a little bit to AI. So you're at SpaceX for about 4 years, is that right? Okay. Did you ever have kind of exposure to specifically when new language models and GPT-3 launched, ChatGPT, et cetera? Did that ever impact your work at SpaceX? Or was it more like, oh, this is really cool, but you weren't like kind of using it in the actual work itself?
Yeah, I was not using it as part of the work there. There are like ITAR restrictions.
Yeah.
And so that's actually one of the things that's been really exciting about being at base and about being here in Austin, is like being surrounded by this and getting the chance to really use it as part of my core workflow.
Sink your teeth into it.
Yeah.
One of the questions I'd like to kind of dig into you with is, what are the opportunities using something like AI, or specifically language model, transformer architecture AI? Like, what does that open up for the world of physical systems, firmware, robots, satellites, et cetera?
This is a good question, and I don't think this is like a nut that anyone's really cracked yet. There are a few startups that are trying to do it, but the way I think about this is basically, how does it change your iteration loop? Right? You have like, you will produce something, then you will test it up until your tests are valid to the point at which you think you have a functional system. It's like how engineering works, right, at a very high level. And one thing that has been really exciting about using specifically language models for producing new applications is your create a new thing step, right? Like generate a bunch of code step is really, really fast. Right? 1,000 times faster on that scale. And it is massively reduced the overall iteration time, because that step was such a big piece of it. But for hardware, your test step is also quite difficult.
Yeah.
And being able to interact in an intelligent way with a physical system to make a change and then flash it to the board, and then be able to interact with another physical system in order to test whether or not you like have been able to move atoms the way that you needed to, I think we're missing some knobs, basically. But if we can get the knobs, then we have an opportunity to really like bring that acceleration to hardware.
Yeah.
Which is actually something that we are working on at Base, basically creating a much tighter hardware iteration loop so that you can interact with hardware and firmware the way you do software.
Yeah, that's very cool. One of the things that I think excites me about AI generated software is it really reduces the sunk cost fallacy of building software.
Yeah.
Where if I spend like 3 hours coding like a base program, and it doesn't really work the way I want it to, I'm probably going to spend another 3 hours at least trying to just fix it or debug it before I just scrap it and go with a whole other approach.
Yeah.
If you just generated it in 30 seconds and it's not architected the right way, or you don't think you can get it to where you need it to, just generate it again. It's not only so fast, but it's so cheap.
Yeah.
You can't do that with hardware because the iteration cycle is longer. You can't really like copy an error code and drop it and say, please fix,
Yeah.
It doesn't really work with.
Yeah. You it depends on exactly what you're doing.
Yeah.
So sometimes you're writing firmware
Mhm.
and the firmware you can generate at the same speed.
Yeah.
The question is, how do you know if it's right or wrong?
Well, exactly. Yeah.
And if you can get your validation loop actually more closer to like your verification or your test loop
Mhm.
to be a lot tighter, then you should be able to just throw your firmware out. But I haven't seen any tools that are able to do this yet. And I think we are missing like a step in the tool chain.
How does
be able to
debugging
close the loop.
work with like hardware robotic systems? Right? Does that like live in the firmware and then you get some sort of error codes that you can use to diagnose, or does it literally just not work and you're like, shit, I got to figure out what's going on here?
It depends on what you're doing and how deep into the product you are. So when we first started Base, like this is, I don't know, first week, with the two co-founders, Zach and Justin, and me in the house that the company was basically started. And I have an inverter on the table that we have like bought off the shelf. And I'm trying to get this thing to accept a charge or a discharge command so that we can install our first systems. And I think I spent 3 weeks sending commands to it and not receiving anything back. And I haven't designed this hardware. I have not written the firmware for it. And so this system is like pretty opaque to me.
Yeah.
And I think this is the like the most inner circle of hell for debugging hardware systems. Like, you don't know how the system works. You don't have access to the firmware, and you're just yelling into the void until something yells back. And that is the worst version of debugging a hardware system.
Yeah, for sure.
But if you're doing it right, which the way we do this now for firmware is you have debug symbols and you have an image that actually will have debug symbols. And so it will like report back to you when it hits certain parts of your code. You can make physical changes like blinking lights to see if the logic that you traced through the code on actually makes sense. You can also, you should be able to run unit tests on your own computer and look through logs like you'll interact with software. So each of these will miss a different part of the system, because either it's compiled differently or you are running tests that interact with your own computer but don't actually interact with the relay that you want to open or close. And you just have to make intelligent trades about what is my understanding of this system and what am I trying to test? And how do I make sure that I, with my various levels of complexity and associated resolution on what I'm trying to test, how do I pick the right spot to test the change I'm making?
Yeah. But either way, it seems like quite a bit more involved than
it's
writing
way
testing
harder. It's much harder. And the dream is basically to make firmware testing look just like cloud software testing.
Yeah. So that's one of the opportunities. Another opportunity that I think is like hot or big, NVIDIA has a product for this. Multiple startups are building this, but simulating hardware in virtual systems. So like create a virtual environment of this room and then put a software copy of your robot in the room and see if it can interact the way it was to generate data that you can then use to train the models. What do you think about that as kind of a possibility? Or
I think, I mean, that is like a provably useful strategy. And one of the things that I think is exciting about the shift in the industry is not only is there a lot of technology that's being produced and a lot of really capable and incredible models that we're able to use now, but the amount of investment, both from the infrastructure side, creating like these huge, huge hyperscale data centers, and the talent side, a lot of people are just getting really excited about the problems. There is a snowball effect that is like clearly occurring. And so being able to do things like that, just having a ton more compute to do simulations for robotic actions, definitely going to move things forward. And then if we think about the problem space in kind of a broader scope, the infrastructure that's being built out, I mean, Base is thinking about this a lot, is also extending to, okay, how do we make sure that as this massive load comes online, what's the next pole in the tent? It's quite clearly seems like it's going to be electricity and power more broadly. And so all of these things are coalescing to just give us more compute to use even existing approaches like these simulated training environments for robotics, and just like basically crank the knob up to 11.
So I think you highlighted one of the core areas that Base is tackling. Let's pivot a little bit to Base.
Yeah.
What is Base Power? What problem are you solving?
So Base is a distributed energy company. And what we do is we deploy, build, install, and operate energy storage systems. And our energy storage systems are distributed in nature. So then what we'll do is we've installed thousands of systems at this point. We actually have just recently passed 100 megawatt hours for installed capacity on the grid, which we're really quite excited about.
Really quick, want to pause on that.
Yeah.
What does 100 megawatts mean in terms of something other people that are not kind of in the space can grasp or understand?
Yeah.
Are we talking like a neighborhood, a city, a building?
Great question. I'd say this is like a small city of worth of storage. Like you have 100 megawatt data centers you used to. And so this is like 100 megawatt hours is like a massive amount of energy to have on the grid.
Yeah.
To put it in some perspective here, if you look at all battery developers, all people that are building battery projects in ERCOT, grid scale, not grid scale, that doesn't matter. Base is by far the fastest battery deployed across the state, like the fastest battery project across the state, bar none.
Yeah.
And so we're deploying a ton of energy onto the grid, and we're still speeding up and still accelerating and starting to, and now we are operating a network of these systems, right? Of these energy storage systems, where we have thousands of these units that are actively reporting, and we are operating an aggregated, distributed energy storage network.
So let's talk a little bit about what operating it actually means, right? When you deploy this system to a customer, it doesn't have energy, right? It's got to pull in energy and then store it. And then what does it mean to actually operate it?
So this is a good question. And let me pop a level up.
Okay.
And talk about how does a power grid work?
Yes.
So a power grid basically has three components. You have generation that produces electricity. You have transmission and distribution that sends electricity from one place to another. And then you have load, where electricity is consumed. And this system is quite simple. If you have one generator and one load and one wire, right? like quite easy in that case. But what happens when you have multiple generators and you want them to run at different times, and you have this graph of a transmission and distribution system in many different loads, it becomes a system that's actually quite complex and really complicated to operate. And so the overall mandate for a power grid is, first, the power should never go out. And second, it should be as cheap as possible. These are the two fundamental principles that power grids must operate by, right?
Uh-huh.
And so in order for it to be really reliable and also as cheap as possible, what power grids will run algorithms that basically say what generators should produce what amount of electricity at what time. And so they are constantly doing these calculations where they say, okay, this generator is using coal and told me that it can give me 100 megawatt hours at $50 a megawatt hour. And that solar plant over there, it's the middle of the day, so it told me it can do $1 per megawatt hour at 100 megawatt hours. And so I want to use the solar first, and then only if there is additional load that is still required to be
Beyond
served
from the solar plant.
well, I call on generator number one, the coal generator, or the coal plant. And so it's this large optimization problem that is constantly being run, and you have a lot of different asset types, and you have to keep your frequency and your voltage in check. And what ends up happening is you have like a minute by minute shift in how much stress on different parts of the grid. You can have some lines that get congested, some lines that have a ton of capacity, and you will try and figure out a way, and this is like the system operator, or ERCOT in this case, will look for a price that not only satisfies the demand, also satisfies the demand in what's called a security constrained way, where you can say, okay, but now imagine that transmission line goes down, or imagine this generator trips offline. We still want to make sure we can meet demand.
Still be reliable.
Yeah, exactly. And so it is an extremely complicated system to operate, and it's massive, right? It's like this statewide network. And
it's statewide, by the way, only for Texas. The rest of the country, it's half of the country.
Yes, exactly. Yeah, there are 3 grids, right? Like East, West, Texas. And so across the country, it gets even larger.
Yeah.
There are actually some reasons why having it smaller makes it a trickier problem.
Yeah.
Right. But let's not get too deep into that one. But you're totally right that it is. There are 3 big ones, and so for Texas, what will happen is you have a new price published every 5 minutes. That is basically an indication of what we need certain operators to generate in order for the system to work. And so you get these large swings in volatility, or these large spikes in price as different things occur around the grid.
It's like a economics supply and demand graph.
Yep, exactly.
Right? And when we need more supply, then we're going to raise the price, which I guess theoretically then should increase
yes,
or reduce demand. Excuse me.
It should. So what ends up happening is it turns out that your demand on the load side is actually quite inflexible.
Yeah.
Or it has been for a very long time. And so most of the flexibility is supposed to come from your generation. But with renewables, and as renewables continue to penetrate the market, it's hard. It's pretty difficult to make renewables what are called dispatchable generation sources. Basically, it's hard to turn off the sun or on the sun when you need it, right? And so because of that, you have more volatility occurring on your generation side, and that generation is great because it is super clean, but more importantly, it's cheap. It is by far the cheapest way to produce electricity. There's no question.
Yeah.
And so what you really want is you want more flexibility on the load side in order to basically soak up a lot of that volatility. And so that's one of the big things that batteries on the grid generally, but base specifically does.
Okay.
And so
you soak up some of that volatility that comes from renewable sources only being on when the sun is on, or at least in the example of solar panels.
Yeah. In the example of solar panels, but that's the great thing about market mechanisms. We don't need to know if it was solar or wind. Like electrons all look the same on the wire.
Yeah.
Right. We just know that energy is scarce at one part of the day, or energy is plentiful at another, and so we can use this filtering mechanism to soak up the energy and put it in the battery when it's plentiful, and then discharge it and give it back to the grid when it's scarce.
Got it. So your customers, this goes back to the operational question.
Mm-hmm.
When you talk about operating the distributed system, you're tapping into these signals. And then for your customers, basically saying, hey, energy is really cheap right now. We're going to soak up more of it so that when it's more expensive, we can give it back to you or back to the grid and kind of offset some of that variability.
So the value prop for the members, the base members, is that if you're looking for backup, base is an absolute no-brainer. If you're looking for energy, like power for your home, still no-brainer. Because what we do is instead of having a very expensive battery that goes on your home that you have to buy outright, say is most of the time you're not using that system. And the grid could really benefit from it. And so instead of you having to pay what is the equivalent of like a new car to put storage on your home, base will come in, we handle the install, we have a low monthly charge, and then we really pay off the hardware by providing grid services back to the grid, which also, because of the market mechanisms that exist, also allow us to do what's good for the grid, which is really what we're here to do, is like work to fix the grid. And so if the grid ever has like localized power outages, which usually are due to like trees falling on power lines during windy times, you'll get backup and you won't notice. It's like a less than a half-second switchover time. And so I've had people call in, the game's on, and all of their neighbors, all their TVs go out, and so all their neighbors come over to watch the game. And then also, because we are able to manage the volatility on price, we can give people a lower than average price while we still pay off the hardware. And so base members usually will have like a 10% lower price for electricity compared to the market. Also, they get backup, and they're doing something good to help support their community's power infrastructure.
Seems like a no-brainer on a lot of different dimensions.
Yeah.
So your role there, you were kind of there when the company was founded, right? And you had to build, I guess, tell me a little bit about your role and your work at Base. Obviously, lots of distributed systems, et cetera, but what does it look like to kind of operationalize this, both on the hardware end and I guess from the operational management end?
So I was the founding engineer at Base. Now I lead all of the software group at Base.
Yeah.
So for software, we have firmware, product engineering, just like the things that our members and people interact with, like the app, the website, that kind of thing. We have markets, which does a lot of data science and predictive algorithms, and also does the communication layer between our cloud systems and our distributed fleet. And then we also have firmware, and firmware, unsurprisingly, writes
abstraction layer between the software and hardware
systems. Yeah. So that is, and then let me see if I hit all the teams there. Firmware, markets, product engineering, also internal software, base operating system.
Yeah.
That's
You've said this a couple of times. I'm curious if we can dig in on it. You call your customers members. They're base members. They're not base customers.
Yeah.
Can you talk to me about like the distinction between that and why it's important?
Yeah. So when we think about base, this is not a transactional arrangement the way it is if we're selling you a widget.
Yeah.
We have a long-term relationship. We are there to protect your home in the event of a power outage. And also you are joining a network and joining a community of folks at base that are all working together to help support the power grid. And so we think of it more like people are joining base as opposed to buying something from base.
Yeah.
And so that's why we call all the folks members.
Cool.
People that
I like that distinction.
Yeah.
It's minute, but it makes a big difference,
Mm-hmm.
especially in the way that they probably think about their relationship to you guys as a company.
Yeah, and how we think about them.
Yeah.
Right? It's our job to be there to support. If any of the members at base have issues, because they're part of our community, we want to be there to help them out.
Yeah, solve it. Talk to me a little bit about where you guys are using AI at base. I feel like there's probably areas where you can use language models, but probably a lot of traditional machine learning as well involved, specifically with operating such a big distributed graph network the way that you guys do.
So there are a few key areas.
Could you real quick too, just move that a little closer?
Here?
Yeah, maybe turn a little bit. Perfect.
Yeah. Okay.
Sweet.
Cool.
Yeah, just want to make sure you come through clear.
Yeah. Thanks. So there are a few key areas where we're using AI, interacting with customers. We have a chat bot that customers can use to get quick resolution on their issues, and then it will route it to somebody on our team, and pretty transparent about that one. Not looking to pass them off.
Faster,
Yeah.
Usually gets it solved. For sure.
Yeah, not looking to pass them off as a person at all, right?
Does your
you should
chatbot
know you're
have,
talking to a
name?
chatbot. Oh, good question. I don't know the name off the top of my head, but I think people on the member experience team do have.
We'll flash it on the screen.
Yeah. Okay.
Cool.
Yeah, it's right here. And so that's a big one. We have a data science team that does predictive algorithmic work, and this is where the line for AI gets blurry, but this is for sure algorithms that are part of the family of AI algorithmic work.
Yeah, definitely.
Like sequential decision making for our optimization functions. And then for development, we're using language models all over the place, right, to do static analysis on code, to generate code. The team very much uses all the classic tools. I guess they're now classic tools that people are using to speed up development workflows. And so these are the big ones. Something that we've been talking about recently, which I'm pretty excited about, is being able to spin up ad hoc tools for our internal software systems. And so this is something that we are starting to explore. Like, can we structure our internal systems to have APIs such that it's really easy for anyone on the team to come and like spin up an app?
Yeah.
This is something that actually a few folks on right now are doing a research project on.
Very
so
cool. Are you guys looking at stuff like MCP to kind of expose your data sets in a way that AI can interact, but you still maintain a lot of control? Or
yeah, we've been looking at MCP. We've definitely looked at MCP because Base is such an operational business, and if operations go wrong, it can be difficult to recover.
Yeah,
like you send somebody to the wrong house to install a battery, it's like pretty hard to hit like Control Z on that one.
Yeah.
And so think we use it more to build tools and to make sure that there are tests there, because for things that are probabilistic, like that stuff works really well internally.
Yeah.
But for kicking off operational processes that have like large downstream effects, that's not something that we've done yet. I think I'm open to it, but I would lean more into like using the internal systems to build tools that are highly repeatable.
Yeah, that makes sense. It's interesting though, like the architecture itself of MCP or of agents, right? MCP basically gives your language models tools that they can then call to do various things.
Yeah.
But like the nature of that is non-deterministic.
Yes.
And so you can't guarantee that the agent is going to use a tool in a way that they probably shouldn't.
Yeah.
I think that's kind of an interesting problem to solve.
And there's some checks that you can add there, right?
Yeah.
You can add validation checks. You can almost think about it as if you can generalize the problem.
Yeah.
right? You are getting arbitrary input in from some location. How do you make sure that the thing you are being asked to do makes sense?
Mhm.
This is actually something you think about on hardware a lot. So you think of cloud instructions as suggestions and never commands.
Interesting.
You just have more context on the hardware than the cloud ever will.
Yeah.
Right. So you know if you're being asked to discharge, but actually you need to be charging because there is solar on site, or the grid, you are not connected to the grid, and you really need to maintain that energy, for example. You would never listen to the cloud for that. And
So you have like ground truth data from the systems itself that supersede this like cloud-based management system.
Yeah.
That's cool.
And an important operational mode for these systems is, like, an operational principle is you need to always fail safe. And so if you end up in a situation where your cloud communication goes down, the system is still reliable, you still back up the house, you're still able to charge from solar that's available. You still have to make sure that the system, even in a situation where your like lossy link goes down, is still like definitely firmly reliable. And
you have like the base logic baked into the system itself.
Yep.
And then when you want to do all the fancy stuff, that's what the cloud will kind of say, but
yeah, exactly.
the hardware can supersede it. Pretty cool.
Yeah.
Is that true for most hardware systems?
Good question. All the ones that I have worked on, I cannot speak for all hardware systems. All the good ones are going to operate like that.
Okay.
You want to make decisions where you have the most context, and you need the fewest number of things to work correctly in order to make them the optimal decision. And so, I mean, our network is a really good example of that. How do you know whether or not you should go into off-grid mode, for example, if the grid has gone down, if voltage starts to dip, and you go to back up the house? You definitely don't want any cloud stuff in that decision making, right?
Yeah.
Because it needs to be extremely fast, and it also, you don't want to rely on a lossy link. So you want to make that a decision like that locally. But if you are trying to figure out what is the optimal distribution of charge or discharge commands in order to stabilize the load on a power line, for example, that is going to be extremely difficult. You could do it in a distributed fashion, but you should not invent distributed systems problems when you don't need to.
For sure.
And
don't
so
reinvent the wheel.
Yeah, exactly. It's like, no, in that situation, you have all the context in the cloud because you have data streaming up. So you want to make the decision there and then dispatch it to your fleet.
Got it. So you guys have been around 2 years now? Company's 2 years old?
Yeah, 2 years
100
old.
megawatts of power distributed.
100 megawatt hours of
100
energy.
megawatt hours of power distributed. How else is the business doing, just in terms of like, give people kind of a sense for the stage and scale you're at and kind of where you're headed?
Got a lot of really exciting things coming up. And so a lot of technology and new developments for the business that we're quite excited about. So right now we have our first gen hardware that we're deploying, and we're actively working on the next generation hardware that's going. It's a fully in-house inverter and battery and gateway. And
so everything vertically integrated.
Yeah, totally.
Nice.
Like PCBAs designed in-house. We're actually recently just announced we are going to be building a factory right on the river here in Austin. Former building of the American Statesman, calling it the Base Factory 1. And we're very excited about building power electronics at high volume right here in Austin.
It's in the heart of Texas.
Yeah, it's gonna be really awesome. We're writing the software that's going to run the factory. We're bringing in a lot of the automations and controls. We're writing the firmware that's going to be running on these systems. It's like deeply integrated and building what we think is going to be the best, fastest to deploy, cheapest deployed per kilowatt hour residential energy storage system in the world.
That's awesome. It's also a really great pivot to kind of the last topic I want to discuss with you, but you guys are buying the new Austin American Statesman building a giant factory right downtown by South Congress Bridge. Kind of like a statement that, like, hey, like you're here in Texas and you're here to stay. Like, I'm curious, what kind of led you? You mentioned you were in SF at Starlink. You grew up in New Jersey, went to school at Columbia. Like, what kind of drew you guys to build this company here in Texas?
Question. So just to clarify, we're leasing the building
Okay, okay.
for what it's
Sorry.
worth. Yeah, no,
More or
fine.
less.
No, yeah. But so Austin is the obvious choice for building this business for a few reasons. One, the way that ERCOT operates, it is just the right market to start in, and also a great market to be a part of.
Yeah.
Um, it works well with the business, and there are exciting ways to grow.
Can you explain kind of why that is? Like, what are the dynamics of ERCOT that make it favorable for that?
So ERCOT's deregulated, or large parts of ERCOT are deregulated, which means that our particular business model, the way we sit between the way that we are able to actually provide electricity to our members and be their billing provider and price them and then also install the battery is a unique quality of a deregulated market.
Okay.
So that's why ERCOT is a great solution for this. Also, ERCOT, the ERCOT grid is something that has been in the news, and we're excited to support it and really just really contribute to the community in that way. And Austin is also a really awesome place to come and build hardware. There is great talent here, but also there's enough space to do things like build a factory. Like building a factory across the street from your headquarters in the middle of the city in SF or New York is not going to happen.
Yeah.
So
literally not possible.
It's not possible. Yeah. And that is an excellent example of why Austin is the right place to do it, because you have great technical talent here and you have a lot of really smart people, but you also have the space and the ability to build big things. And that's what we're here to do. And so Austin was the obvious choice.
Nice. And when you think about expansion and growing the business itself, ERCOT, obviously the perfect starting point. You can build a pretty big company probably just staying in ERCOT, but it seems like your ambitions are probably quite a bit bigger than that. What does it look like to break into those other, like the East grid or the West grid? What are kind of the dynamics that you're going to have to figure out a few years down the road as you continue kind of growing the company?
So we are talking to potential utility partners right now, have a few pilots running with like more regulated areas or more regulated entities. And so we are actively working on this and are excited about working with more utilities. The deregulated area is the place you start. It's like this is what I would think of as the wedge for the business.
Yeah.
Because it has allowed us to get to a scale at which we really understand how to deploy energy storage at a high rate, manage it so it's super reliable. We're hitting reliability that's above what typical grid scale systems are at, for example, and be able to demonstrate that we really know how to operate a network like this, and learn how to do it, build new hardware, and then the extensions of the business I expect will be we're going to continue to grow in the deregulated area, but also bring on more partners to be able to help them balance their grids and be able to offset infrastructure costs and be able to balance voltage and phasing for the grids across the country. And so this is a really exciting opportunity that Base has to help not just the Texas power grid, but the power grid across the country and potentially across the world.
Yeah, it's a good case study.
Yeah.
You can validate, show all these happy members, and also really great benefits from the infrastructure side. And then why wouldn't these other places want to work?
Yeah. Yeah. And we're really excited to do all of that, starting and with the seed right here in Austin.
Yeah.
It's like our HQ is here. This is like the soul of the company. And we think that excited to bring some Texas culture to the rest of the country.
Yeah. Well, I'm excited to have you guys here because y'all are a magnet for great people moving, right? Great people are already moving here, but the more great companies that are here, the more great people move here. Like, I'm curious, obviously tons of hardware talent here. Also a lot of great software talent. I think
There's
Austin and Texas in general has a very underrated kind of like software engineering community, very talented builders. But at the same time, it doesn't have kind of this, you know, top tier image in the world the way that like a San Francisco does. Like, oh, if you're building AI, you have to be in San Francisco, et cetera. Like, what do you think we can do better as an ecosystem to attract better engineering talent, but also better kind of highly technical AI focused companies and startups and scale ups?
I think that one of the big ones that we were actually talking about earlier, building more technical community here in Austin, people that are really here to build things, work on hard problems, are excited about doing it with other people that are like technical and want to build stuff is the best way to do it. And that the process, I, I think it's underway. It's like we are seeing a lot of talent come to Austin, and very often we'll talk to candidates, and even candidates that are on the coast will say, "Oh yeah, actually I have been thinking about moving to Austin anyways. My friend's there, or I've seen a lot of really cool companies."
Yeah. Heard good things.
Yeah, exactly. So I think that that's one of the big ones, and then the other one is we just got to keep building hard stuff. It's like I think most of the most exciting projects right now are happening in Austin, right? It's like 3D printing homes or jets or building big battery networks or building nuclear. Like a lot of that work is happening right here in Austin, and it's happening here for a reason. I think we just got to continue making big bets and taking on really hard problems. And most of those problems are going to be physical in nature at some point. Right? I think that we're basically going to, like, LLMs are going to make a lot of the software only problems pretty much solved for the next few years. And the iteration loop is going to become, how do you start to impact the physical world? And you need space to do it, you need energy to do it, and you need the right people in the room.
Yeah. And that snowball of more people studying physical systems, et cetera, working in companies there. Like, you're right. This is the logical place if you want to build that type of company to do it.
Yeah.
So I'm really optimistic about it. And
Yeah, me too.
stoked to have you guys here. Cool. Well, let's move into some rapid fire questions. So they don't have to be that rapid, but I'll just kind of like rattle them off really quick. First question would be, what is your favorite LLM? Like, just your daily driver that you just use when you need a question answered.
Grok.
Grok?
Yeah.
Right on.
Yeah. Actually been using it a bunch, and it's pretty awesome. Also great for coding.
Yeah.
Yeah.
I haven't used it for coding.
Yeah.
Just like kind of random questions. Cool.
Okay.
I think that's the first Grok. A lot of people I've interviewed have picked Gemini, actually.
Really?
I've been impressed with it.
Interesting.
But it's not my daily driver. I'm still kind of at ChatGPT.
Yeah.
I use Claude for coding.
Yeah,
Claude
like
for
a
coding. Basic stack. Yeah.
It's excellent.
Okay, so next question. What's a book, podcast, like piece of content that has given you a framework that influences like how you live or also how you work or just navigate life?
Interesting question. We were okay. This is a pretty general one, but talking about like economics a little bit earlier.
Yeah.
And I think utility functions and the fact that different people will have different utility functions, and thinking about how somebody's like equation for what makes them think something is good or bad is different than my own, allows me to understand something I think about a lot, and allows me to understand the people around me. Like, why do we want to build something in one way versus another? And this is a framework that I like use frequently.
Nice. That was kind of my next question too, which is like favorite economic concept.
Yeah.
I really like the idea of comparative advantage. It always just made so much sense to me. You do math and it's like, yeah, we're great at apples, you're great at cherries. We both get more of each. If like I focus on apples, you focus on cherries.
Yeah.
Yours, I guess, would be utility functions.
I think I want to pick a different one on that one, actually.
Okay, sure. Yeah.
I think diseconomies of scale is really cool. It's just like a funny concept.
Okay,
Like,
tell me about that.
Economies of scale is, I think, a pretty obvious one, and also a massively important piece, especially when you think about things like manufacturing or hardware. But there's this concept where eventually you can get to such a scale that I'll give an example. You have a factory that's so large that you have to like take a bike across the factory. And so eventually you cannot walk across, and to talk to that other team, it has become much less efficient because you've gotten so large.
Yeah.
So it is just kind of a funny way to think about, you have basically like a U shape on your economies of scale, and how your efficiency increases as you scale up.
Interesting. That makes me think of, I visited the Meta campus in Palo Alto. They have an entire internal shuttle system with like full-time employees managing it, schedules posted at bus stops, etc.,
Awesome.
just to bus people from building to building.
That's
It's like, how much overhead and infrastructure are you creating, as opposed to just like having different offices where everybody kind of has it there and just doing Zoom calls if you need to go across.
Yeah, totally.
It's a good example.
That's super funny. Wow. Yeah, that's a good one.
Yeah, it blew my mind. I was there for like their llama conference, and they're like, oh yeah, you're going to catch the shuttle over to this building, and then you're going to go 5 minutes down the hall and take 3 lefts. And I was just like, God, this is crazy. Next question. This is my Jake mug. I asked this question to everyone. So if you had a mug, what would go on your mug? Could be like words, a phrase. Can't just be your name, unfortunately.
But you get one with just your name.
Yeah, I know.
Okay.
I have a quote that I would put on there as well, but no, it can't just be the Jared mug. It needs to be.
This is a quote that someone on my team gave me recently, which I think is really awesome. And it is that let's see if I remember it well. All successful complex systems have like a simple kernel, or like a simple seed. And they're all built out from simple systems, but if you want it to be an effective system. That's kind of long for a mug, but that's what I would throw on there.
Oh, it's great. I interviewed one of the founders that way back at Antler, and she's building like very complex AI systems to help validate scientific research. Huge problem in the world. And hers was just go outside. She kind of gets in her tunnel, and like doesn't talk to people, and every once in a while just go outside, touch grass. Like,
I love it. That's cool.
Okay, last rapid fire question. What's your favorite like nice restaurant to go to in Austin? Like, it's a date night or like some elevated occasion. I think too many people ask about breakfast tacos. There's great restaurants here in town. So I'm curious if you have any recommendations.
Uchi for sushi.
Yeah, that's a good one.
Yeah, it's a great one.
Do you have any others?
Oh. I think that's my big one.
It's great.
Yeah, restaurants are not my.
I don't mean to minimize it.
No.
You just said for sushi. I was like, oh, he's got one for pasta and one for Mexican food.
No, restaurants, like that stuff has never been my my forte. But I'll give a different plug.
Okay.
Southern Walnut Creek Trail.
Okay.
An incredible biking path.
Yeah.
For sure, the best one I've ever seen, and is like a 50-miler, and is. If you do a lot of biking outdoors, it's like a really great one.
Nice. I'm not a biker, but I did go on a hike there once with like a big group of friends. Yeah, that was great.
It's awesome. It's super cool.
Tons of trails and stuff. Right on. Well, wrapping into closing, I think first question is for anyone that wants to stay up to date with you, with Base, etc. Like, what are the best places to find you or follow you?
Yeah, you can find me on Twitter, or X, Jared M. Greene, with an E at the end of Green. That's the best one. And also sometimes I'll write blog posts on the Base Power Company website.
Nice. And then last question, what are you excited about personally with Base, etc. for the next 12 months?
for base, I'm very excited about opening up a factory right here in Austin, continuing to build out the team. We have a lot of really incredible people and we're continuing to expand. So if people are looking to get involved in a really cool project,
Hit up Jared.
basepowercompany.com.
Shout out basepowercompany.com.
And then personally, I'm by the time this airs, it will have already occurred, but I'm proposing to my girlfriend this weekend. So I'm pretty excited about that.
Congrats, man.
Yeah.
I get married in 2.5 weeks.
So. Oh, awesome. Whoa.
Yeah,
congratulations. Where are you going?
Dude, congrats to you.
Yeah, thanks.
We're doing it here. We're going to go to Hawaii for the honeymoon.
Cool.
Which I've never been to, so I'm pumped about.
That's awesome.
They have their own grid in Hawaii, right?
Yeah.
I'd assume so.
Ton of solar, very high solar and battery penetration.
Yeah, makes sense. Super sunny, so probably works really well.
Yeah.
Right on. Jared, thank you so much for being here, man.
Yeah.
This was an awesome conversation.
Thank you. Thanks for having me. A lot of fun.
Absolutely. Yeah.